Good morning. Happy Thursday. Today is day 137. By now, we're pretty far into class. You have already completed today's exploratory problems with your partner after you had analyzed today's objectives and key terms. We already had a class discussion in which you participated where we worked through the exploratory problems, some of the purple box problems to get you started. And you, along with your partner, should have been using those skills to complete the blue practice problems. This is our video recap now. At this point, we're taking a look at some of the practice problems after we looked at these purple problems. Today, they were linear systems. We worked on finding the most efficient or the best strategies to use based on what we see in the two equations or the linear system we're provided. Two of the big things we focused on were substitution or elimination as two of our main methods when we're just given two equations for a linear system. Graphing, of course, if we see graphs or if we're good at making graphs, is always an option when we're working with linear systems, and we'll talk later about inspection. So we're going to focus on these four problems here for practice problem number 1. Each one of them was a linear system, and they said for each of them to identify the most efficient strategy to use that strategy to determine any common solutions, and then finally to confirm your answer is correct at the end. So we're going to take a look first at this red equation. It says negative 2x plus 3y equals negative 10, and the other equation 2x plus y equals negative 6. If we're given a linear system and we're asked to determine the common solution, the first thing we want to know is what is the best strategy to help us with this type of linear system. We're going to look at this linear system in full screen on the whiteboard, and what we see in a linear system where you see two variables, the same variable, the x is a positive 2x and a negative 2x, they're inverses of each other or opposites. This type of linear system is perfect for elimination. We should have recognized from class earlier and our work on Monday is whenever we see a negative 2x and a positive 2x, or any situation where the x's have coefficients that are opposites of each other, if we just add the two equations together, the x's will eliminate each other. So we'd be left with 4y equals, and then if you combine negative 10 with negative 6, you should have got to negative 16. At this point, you all should be good to go the rest of the way to find a common solution to confirm that it's correct by plugging it back into these two equations. The second linear system we're provided with, the green equations here, 4x minus y equals 16, and x equals 2y minus 3. This linear system, I think, would be best solved if I see something just says x is equal to some other expression. I'm typically going to want to go with substitution. Some of you may have seen elimination. You would have to work with one of these equations to set this up for elimination first. So because there's nothing that can obviously eliminate right away, 4x and x would not cancel out, negative y and 2y would not cancel out. I could have multiplied this whole equation by 2, but that seems like a bit more work than just plugging in 2y minus 3 for the x over here. So this expression, 2y minus 3, has the same value as x, so that can plug in for the x over here. Becomes 4 times 2y minus 3, because that's what replaces our x from over here. Still going to subtract y, that equals 16. This required you to use the distributive property. 4 times 2y would give you 8y. 4 would also have to multiply with the negative 3. That gives you negative 12 minus 1y equals 16. You can combine the 8y and the 1y, 7y minus 12 equals 16. And at this point, we're going to leave you on your own to figure out the rest of the common solution. You can solve for y, use the value for y to determine x in one of these equations, and then confirm you're correct. The third linear system we were provided with in purple, hopefully you recognized, again, similar to the red linear system, we have a negative 2x and a positive 2x. Those would eliminate each other. But the challenge for this linear system for some of you may have been when I stacked these equations up, to eliminate the x's. Negative 2x plus 5 equals y, and 2x plus 4y equals 26. When we go to add these equations, the x's eliminate. But this time our numbers, our variables, are on different sides. The 5 for this equation is on the left expression with the positive 4y. So we can't add those together. We just represent this as 5 plus 4y. Over here, y and positive 26 are not like terms. So that's just represented as y plus 26. This equation should look familiar to what we saw earlier this year. We have two variable terms, but they're both a y. They just happen to be on opposite sides, so we're going to need to use inverse operations, just like we would use inverse operations to get the 5 and the 26 to the same side of the equation. Again, we're going to leave you on your own at this point. If you need help with this, work with a partner, talk with me, Ms. Stewart, Mr. Chu, but you should be able to solve an equation like this to get for y, and then work out the rest of your common solution and check your answers. Final equation, y equals 2x plus 6 and y equals 3x minus 4. And for that linear system, you have a few options. One strategy you could have used here is to graph. Could have actually graphed that, especially if you like graphs and you have one available to you. Both of these are in slope-intercept form. But I would actually use substitution when I see this, because I see both of them, 2x plus 6, that expression is equal to y, and negative 3x minus 4, that expression is equal to y. I know that the right expression, 2x plus 6, has to have the same value as the right equation in the right expression in the second equation. If 2x plus 6 is equal to y, and negative 3x minus 4 is also equal to y, these two expressions must be equal to each other. And at that point, you'd have an equation with all x's. Again, we would have to use inverse operations. We'll help you a little bit here. One option could have been to add 3x to both sides. That would gather your x terms. On the left expression, 2x plus 3x could become 5x, negative 4. And then at this point, it's just a two-step equation, peeling the onion like you would have done with Mr. Neville, or isolating this x by using inverse operations. You could work the rest of the common solution out. Thanks for watching the end of the video. Good luck the rest of the way.